when I submitted a talk for this conference, I actually submitted this talk, which was the one was accepted. And it's basically, as you can see, it's the part 2 of something that I've done before, and I would have done JIT and GC. This was the original talk that I've given here last year. Who has seen that talk from last year? Anyone here who has seen this one? Okay, that's good, and you'll see in a minute why. So what happened was, this talk is about this machine learning framework that we're using at Twitter to tune for performance, right? And so I'll show you all the data from one of our or 2 Twitter services that we're using, and you see a lot of graphs and data. It's very interesting, of course. The problem was that when I wanted to do the second one, where I tuned the JIT compiler and the GC at the same time, the machine learning framework didn't cooperate with me. So it didn't do the things I wanted to. It stopped running and so on. Then last week, suddenly we had an internal networking outage, so things didn't work out the way I wanted them to work out. So basically, what we can do is 2 things now. And it depends on what you want. And you have to vote now. So I can do this talk, where you see how much CPU we're saving, how much GC we can reduce, and so on, which is like a technical talk, and it takes about 50 minutes. Or I'll do the one that's advertised, which is called Performance, which is a completely non-technical talk. It's a very inspiring talk about performance, and you will see what that means. So who wants this old technical talk? All right. Who wants the performance one? Okay, we'll do the performance then. Excellent. I like it better anyway. Good. So who am I? For the people who don't know who I am, and I'm not wearing my Twitter shirt today, so people don't know who I am. My name is Chris Thallinger, and I work for Twitter, right? So most people use Twitter, I'm assuming, I hope at least. And you should certainly tweet about all the talks you've seen and all the cool talks you've seen about DevNexus. I think every talk was recorded, so tweet about the ones you liked so that your colleagues and your friends can rewatch them later on YouTube. And what I'm doing at Twitter and for many years is I'm a compiler engineer, right? So compiler engineer, if you look up what a compiler is in the dictionary, and I kind of have to walk a little bit over here because I'm presenting from my phone and the font is really small. A compiler is a person who produces a list or book by assembling information or written material collected from other sources, right? Sounds interesting, it's not what I do, right? There's a second definition of a compiler, and it says a program that converts instructions into a machine code or lower level form so that it can be read and executed by a computer. That's what I do, right? I work specifically on JIT compilers in the JVM, right? So I work on compilers that compile some form of source code into native instructions. And in particular, I work on something called optimizing compilers, right? So, and as you can see, common requirement, well, at the beginning it says optimizing compiler is a compiler that tries to minimize or maximize some attributes of an executable computer program. Common requirements are to minimize a program's execution time. That's basically what we all want from a compiler. Memory requirement, we all have memory problems, and power consumption. And it says then the last two being popular for portable computers, which is absolutely true, because we want our phones and our laptops to run as long on the amount of battery they have as possible, right? But the latter two are becoming much more important these days in our data centers as well. And this is the title of the talk, which is kind of a little bit misleading, and I wanted to get you in the room, and then I surprised you with the real thing. What it actually should be called is Performance and Our Impact. So that's what this talk will be about. So let's look into something. I think, and I might be wrong, I think software development today is a lot dictated by these things called sprints, which I've never done in my life, so I don't even know what it is. So I actually had to look it up on the Atlassian website. It's a short time box period where a Scrum team, I don't know what a Scrum team is. I really don't. So you can explain it to me later. works to complete the set amount of work, right? Okay, sure. There's another definition on the Atlassian website, which says sprints make projects more manageable, allow teams to ship high-quality work faster and more frequently, and gives them more flexibility to adapt to change. Is that true? I don't know. So the thing that I'm worried about is this part, the faster and more frequently. And I hear this a lot from people complaining, basically, because the people who are actually doing sprints and all these agile work and I don't know what, your manager and your company pushes you to get features out as quickly as possible, right? That's what I hear all the time. So, you get this feature done this week, and then next week you have another sprint, you have to do this, and so on and so on and so on. So you never have time to sit down and actually think about what you just wrote, and especially the performance of what you just wrote. So let me tell you a small story. When I joined Twitter in 2016, and I came to Twitter, I basically brought Graal, the compiler, to Twitter, and through that we saved a lot of CPU consumption. I heard of this team, and I don't know which team it was, and I wouldn't tell you if I would know, but I heard of this team, and they had a lot of memory pressure, right? So they had too many GCs, too long pause times, and so on. And so there were 3 people, and they decided, okay, let's try to change our code to not allocate as much memory, right? So they sat down for 2 weeks, and we're working on the source code, refactoring it, and I'm very sure, and because I'm sure you've done similar work in the past, the code was not as nice as it was before, right? Because if you're trying to get rid of allocations, you have to factor the code in a way that's just not as beautiful anymore as it was before. So they did this for 2 weeks, and then after the 2 weeks, they ran whatever their service again, and guess how much memory they could save? 0. And the reason for this is because there is a small compiler optimization technology called escape analysis. So all the objects that you as a human could find that are not necessary, the computer already finds for you. And more than that, right? Because the compiler, that's just what a compiler does. So the point of this whole thing is you should know your compiler optimizations and don't be too smart. And because I'm working on the JVM for a long time now. I used to work at Sun and Oracle in the Java platform group, so I was working on Java. And very often people ask me, how should I write my Java code so that the JVM JIT compilers can compile it the fastest to get the best performance, right? And my answer is always, write the code as it's supposed to be. If you're too smart, you are basically outsmarting the compiler. The compiler is not an AI. It doesn't have a brain. It cannot think. It's a pattern matching machine. If you're breaking the pattern, we cannot match the pattern. So don't be too smart. And you should certainly, if you have some time, maybe read that Wikipedia entry on an afternoon to know what optimizations compilers actually do, so you're not doing the same mistake as our engineers did. This is something that will become, or maybe already is, very, very important: data center electricity usage, right? Everyone's moving to the cloud. No one has their own hardware anymore except us. We own our own hardware. So I found this article on the Google website, and it says data centers and machine learning, so we'll get back to that later. But in that paragraph down here, it says 2% of the world's electricity today is used by data centers alone. 2%. Might not sound a lot, but it's basically everything we do in the world. So it is a lot, right? 2%. So this is from it's the energy forecast, and you see the different colors, obviously, and we are now in 2020, so like in the middle of somewhere. I'm very interested in the green one, right, the data centers. As you can see, in the next 10 years, this will triple or quadruple. So we are moving more to the data centers, more to the cloud, and the one thing that's very different today than it was, let's say, 10 years ago, is 10 years ago, if you wanted to have more compute power, You actually had to go to either a store or a website, configure a server, order it, they assemble it for you, they ship it to you, you put it in your data center, you hook it up, install it, an OS and so on, and then you can run more. Today, the only thing you need is a credit card, right? You go, if you're just using too much CPU over there, you don't even care, you're just buying more. And that's that, right? So we can't go exponentially like this. We have to think about this a bit. So the good is, in all this, that the big companies, the big data center cloud providers are trying to mitigate that a little bit. So Google is very good. As you can see in already 2017, Google achieved a major milestone. They say they're purchasing 100% renewable energy for all their data center electricity usage, which is great, right? The only problem I have with this is if they are buying it, we cannot use it somewhere else, right? It would be much better if they would use less and we use the renewable energy somewhere else. But they're doing good works, and they are also building, I think, is that the next one? Yes, this one. I found this very nice tweet. It's actually a video. You can, like, the link is at the bottom. Google is building a new, I think a solar farm or whatever this is, and they bought an old coal-fired power plant and tore it down, and then now they're building a data center there, plus, solar panels and so on. So I found that cute, to get rid of the old technology and replace it with something more modern and more green. Amazon, so they said, has announced, at the top, so they want to do 100% renewable energy. Currently, they exceeded 50% renewable energy usage for 2018. I'm not exactly sure what that means, but I'm assuming 50% or a little bit more in 2018 was renewable. They announced all these projects to build the wind farms and solar farms in Ireland and Sweden and in the United States, and they will produce 297 megawatts of electricity. And at the very bottom, it says 2.9 terawatt hours of renewable energy annually. So that's great, and I think that's the right way to approach this, really, is if you're building more data centers and the companies who are building the data centers are actually trying to offset that with new renewable energy that they are building themselves, then it's fine. Then it's actually better if everybody would move to the cloud, right? Because if you have your own data center, you probably don't have your own solar farm. I don't think you would. So I like this move. Microsoft, that's not good. I didn't do anything. I need a stationary bike to produce my own energy here. Okay, here we go. Microsoft. This is something I didn't know. It's very interesting. Microsoft employees in here. Maybe you can confirm. So what they have is they have an internal carbon fee, right? And it says they just doubled that to $15 per metric ton on carbon emissions. So basically every team at Microsoft, if they're using too much energy and producing carbon emissions, they have to pay for that. And that's the only way that your manager lets you think about performance, right? Everything, even in our industry, everything that goes, let's put me another way. No one really does anything good for the environment just because he's a nice person. It's all money driven, right? It's all money driven. And this is one way to actually drive from top down, because if you as an individual care about it, sure, nice. But if your manager doesn't let you think about the performance, what can you do? But if your manager has to pay for it, then that will change something. The bad, if there's a good, there's always a bad, is this. So that's the International Energy Agency, and that's from what's right over there, I can't read it. A long time, 30 years, 1980? What's all the way on the left? Okay, up to 2017. And as you can see, yeah, there are some renewable energies popping up at the very top, but it's not a lot. And if we put that into percentages, it looks like this. One thing we can clearly see is that coal, sure, it goes down a bit at the end, but it's actually getting more, right? We're building more and more coal-fired power plants. Natural gas is, I don't want to say exploding, but it's definitely getting more, and we all know this. We all know of fracking and so on, and people want to tell us that natural gas is a clean energy source. I don't think it is. Nuclear is going down because we think we cannot control it, right? We had Chernobyl and all these things, and so that's going down. Hydro, I think, stayed about the same. And then you see at the very top, I mean, how much is this? 4%, 5%? It's mostly, I think, wind. But we're still far away from being, completely renewable. Far, far away. So you remember this one? And I said we'll get back to that. And the title is Data Centers and Machine Learning. So I want to talk about this guy. And what they did is they used machine learning in the Google data centers. And so his name is Jim Gao, and he was just interested in machine learning and took an online class to find out a little bit about machine learning, right? So he did this, and one of the reasons why he was interested in this, and I mean, everybody knows this, I'm assuming. I'm just putting it up so that we think about it again. If you have 10 pieces of equipment in your data center, and one of this equipment just has 10 settings, which is not a lot, you have 10 to the 10th power different possibilities of settings, right? Which is 10 billion. So a human would not be able to do this. But machine learning does exactly that for you. That's also what we did at Twitter, right? With our Bayesian optimization stuff. That's exactly it. So they applied this machine learning, and then they piloted the project, and they said they have reduced 40% reduction in energy used for cooling, which is basically, I'm assuming, just the arrangement of equipment in a data center. How do you set it up so your cooling is more efficient? And then a 15% reduction in overall energy used, which is great, right? I mean, that makes it cheaper to run, it makes it more environmentally friendly, and so on and so on. So, and then, although this was very successful, they think they only scratched the surface of the machine learning's ability to help with that problem. So let me give you a Twitter example, and since no one wanted to see the other talk and no one has seen it, I'll show you a couple of numbers now. So what we've done is, this is a comparison between C2, the JIT compiler in Hotspot, that's the default today, so basically all of you are probably using C2. And then in orange, we are using Graal. If you have been in this room right before my talk, I think there was a Graal talk. So it's like a new JIT compiler that produces better code, especially for our Scala code base. And then the red one is Graal with machine learning applied. So basically what I did is I tuned 3 inlining parameters for Graal and tried to get the code faster. That's what I did. And as you can see, this is allocated bytes per tweet. So how many bytes do we allocate to process one tweet? That's the tweet service. So it's basically reading and writing tweets. And we could reduce 3.5% of allocated bytes by just using Graal instead of C2, but then again, 3.4 with the machine learning. So about 7% less memory allocated per tweet processed. That translates into 7% less GC cycles, right? And we all like that because we know if we have less GC cycles, our latencies go down, right? That's exactly what you can see here. It's very clear that Graal, the orange line, is better than the blue one. It's not so clear that the red one is better than the orange one, but you can also see it. But one way to look at this is if you integrate over the 24 hours here, you can see we reduce P99 latencies by 20% just by running on Graal, but then another 8% with the machine learning on top. 28% less. That translates into, because we are doing less GCs, which means we don't, first of all, we don't allocate the memory, which makes the code tighter and run faster, but also GC cycles take up a lot of CPU resources, right? So we can reduce CPU, as you can see, 12 plus 6, like 18% of CPU by processing the same number of tweets. That translates into 18% fewer machines and less electricity. So we run the same, we process the same amount of tweets, but we use 18% less machines, which means a lot of money that we're saving, right? So again, it's kind of money-driven. I did this because I'm a good person. Yeah. I didn't get any money for this, to be honest. It's outrageous. They should give me at least a cut of this. So fewer machines, less electricity, so lower electricity bill, less cooling in the data center, blah, blah, blah. You see where this is going. Who knows what that is? It's my favorite topic. Bitcoin mining. People with Bitcoins leaving the room now. The reason why I like it is, number one, because it's outrageous what we're doing. But number two, it's a very good example. If we want to optimize something, we can, and you will see that. So this is already a bit older. It's like from September, but there's a Twitter handle that tells you the energy footprint for one Bitcoin transaction, and in September it was 606 kilowatt hours for one transaction, which, as you can see, translates into running a US household for 20 days, or a German household for 63, or a Chinese household for 170 days. One thing you can take away from this, America could use a little less energy in your houses. 288 kilograms of carbon emissions, just one Bitcoin transaction, right? This translates into 78 terawatt hours per year just doing Bitcoin mining. And Bitcoin mining has become like an industry. It's not you and me at home with our computers on our laptops, haha, it's fun. This are farms, it's a big industry. And these 78, the Cambridge Bitcoin Electricity Consumption Index, it's a very interesting website, is as much energy as Venezuela, Chile, Philippines, or Belgium use in a year. So these countries are very big. That's the population of these countries. Like 100 million Filipinos use the same amount of energy that we are wasting on a cryptocurrency per year. That's the energy consumption over time, and it starts in 2016. There are 3 lines here, and that's because Cambridge doesn't know exactly what Bitcoin mining hardware people are using. So the one at the bottom would be everyone's using the best hardware that's out there. The gray one at the top is like not really the worst one, but not as efficient. And then in the middle, that's the average what they think people are using, right? So I'm very interested in this scenario here. You see, something happened there, right? The electricity consumption of the Bitcoin mining network went down quite a bit. And to find out what happened here, because it went down from estimated consumption 51 to 30, so almost halved, which is quite dramatic. This is what happened. The Bitcoin price went down from $6,000 to $3,000. It's all money driven, right? As soon as there's not enough money in the thing, people stop doing it. No one ever thinks, let's stop doing this mining because it's not. This is, you can't read it, it's too small. It's every country in the world, how much it costs in US dollars to mine one Bitcoin, right? So that's very important because number one, it's how much electricity is, and number two, it's also what the climate is in the country, right? You find Bitcoin mining farms now in colder countries because, it's cooling down. I took out a couple. So $530 in Venezuela. If you want to mine Bitcoin, move to Venezuela. Then, that's by far the cheapest, by the way. Don't do it in South Korea, right? You would lose money. Bitcoin price right now is, I think it went up to $10,000 again, but still, you would lose a lot of money if you do it in South Korea. I wonder if someone's actually doing Bitcoin mining in South Korea. It would be interesting to find out. So this is the other interesting part of Bitcoin, the history of the mining hardware. So in 2009, basically Bitcoin took off, and then everyone had just standard computers at home, They probably had 2 CPUs, I'm assuming, back then. And so they were just mining for the fun of it, right? 2009. 2010, a year later, the standard multi-core CPUs were already too slow, and they started using GPUs for it, right? GPUs, you can do a lot of things in parallel, so that was pretty good. And then more dedicated GPU hardware actually came out. 2010. 2011, not even a year later, it was only like 6 months, I think. They stopped using GPUs because that didn't work anymore. They used FPGAs. And then you see by June 2011, they used FPGAs. And then in the same year, 2011, probably November or December, end of the year, they stopped using FPGAs. They weren't fast enough anymore. They were actually producing integrated circuits. Like they're fabricating Bitcoin mining CPUs. That's the only way how you can make money these days on Bitcoin. But I find it very interesting. If we want, this is just 2 years, right? If we want, we can optimize the shit out of it if there's enough money behind it. So these are just a couple of other examples that I find very interesting. Video game companies make big climate promises. So it turns out, I hope I can read all this now. So there are different promises that the video gaming companies make, from planting trees, nice, reduce plastic packaging, obviously, right? Making game devices more energy efficient. I think that actually would make an impact because there are a lot of gaming consoles out there and they're running a lot, right? They're on for hours and hours and hours. To incorporating environmental themes into the games themselves. And I think that's very important. Because if we get these environmental themes into the games that our kids are playing today, they will grow up with a hopefully different mindset than we have. It still will be money-driven, but maybe they care a little bit more about it. Then, with an estimated 2 billion video game players globally, so this guy, David Paul, is the environment minister of the Marshall Islands. If you don't know the Marshall Islands, they're in the South Pacific. The Marshall Islands with the Christmas Islands will be the first islands that will disappear from the face of the earth because they are so low-lying that just 1-2 feet and they're gone. The thing that happens first is it's not so much that the whole land will just go underwater. What happens is the sea level rises so much that it poisons their freshwater table. And then when the freshwater is poisoned, all the plants die. That's what happens first. It's not the people, it's the plants die first, and then there's nothing to eat. And then they have to move away. So he says, with 2 billion video game players globally, this is the most powerful mobilization channel in the world. It's basically coming back to the environmental themes in the games. So he thinks that would make actually an impact. And Sony says they're outfitting the next generation PlayStation system with a low-power suspend play mode. I'm not exactly sure what that means, but it's probably, you can put it in low power when you're just not playing and grabbing a drink from the kitchen, or I don't know what, or just leave the console on so you don't have, you are where you are when you start playing tomorrow. I'm not sure what it is. But he says if 1 million players use it, they could save enough electricity to power 1,000 average US homes. Yeah, sure. I mean, it's not a lot, but I'll take it, right? If I can get this for free. You remember this graph? Yes. We looked at the green, but now we'd like to look at the blue, because the blue is the other one that goes up exponentially, and blue is networks. It says wireless and wired. So the more data we have to move around, everyone has a phone, 4G, 5G, there will be even more data. That's probably one of the reasons why this goes up like this. We have to shuffle a lot of data around. No one's watching TV anymore. Everyone's streaming from Netflix and YouTube and Hulu and God knows what. So data reduction and caching will become very important. It's also, again, if you don't have to move things across the network, it will cost you less money to do it, right? So even for you, it's interesting to do data caching and data reduction. Let me give you Twitter as an example here. We introduced this in April 2017. it's called Twitter Lite. I'm not sure if people know about it here. We introduced Twitter Lite for developing countries. Because in developing countries, people only have 2G, right? And then you can't have all the high-resolution images being loaded on your phone, in your timeline, or video auto-playing and all these things, because it would cost them too much money. We didn't do this because we're nice to the environment. We did this because it was too expensive for these people to use Twitter. And actually, this made it into the official client. So that's a screenshot of my Twitter app. And as you can see, you can turn this data saver mode on, which barely anyone has, right? Because everyone has unlimited LTE data. So, yeah. But you can. You can reduce the quality of the image you have in your timeline, the autoplay feature, and so on, which would absolutely reduce how much traffic there is on our networks. This will become very interesting and important content delivery networks, right? We want to have the content closer to the consumer for two reasons. Number one, the latency is lower, right? And you get your video loaded faster. But most importantly, the graph with the electricity consumption. It's a little difficult to get good images from the big data center cloud providers, but this is the best I could get. So Google, you can see these are their data centers. The thing that's missing here are the edge nodes, right? You have all these edge nodes in bigger cities and so on, metropolitan areas where you have a lot of people, but I couldn't get them into one graph, so this is all I have now. You can see it's very focused on North America and Europe. There's a little bit in Japan and in Asia over there. Very interesting, there's only one in South America, only one data center in South America, none in Africa, and they have one in Australia. This is Amazon, and it's basically the same picture, right? It's very North American centric, Europe, then over there, Japan, China a bit, one in Australia, same, one in South America, and then they're planning one in Africa. So the more we get closer to the people who use it, and Africa will explode in population in the next 10, 20 years. So this will become very important. And then last but not least, Microsoft. The picture is slightly better, but it's still very US, Europe-centric. They have one in South America, but at least already two in Africa. They actually have 4 in Australia, and then a bunch of sprinkled around over there. So do I have a slide on the, no, not really. So I've shown you a couple of examples that actually performance tuning has an impact. Right? It's not just for fun. I mean, it is fun. If something runs faster, it's just fun. But there is actually an impact. You are making an impact, maybe beyond you were thinking you would. You've seen the example with what we do at Twitter with machine learning. You've seen the example what Google is doing in the data centers with machine learning. You've seen the Bitcoin example. Very interesting. So it absolutely does make an impact. So the only thing I'm asking you to do is stop every now and then and think about the impact of your work. Thank you.